Hey everyone, in this video we're going to be talking about binary searches, what it is, why it's cool, and how it can help you too. So say you have a sorted array of numbers, 1 through 100 or 1,000 or a million, and you're trying to find a particular number in there. 57 for example. How do you do it, right? The most basic thing you can do is check each element and say, okay, is this first one 57? No? On to the next one. Is this 57? No. Okay, on to the next one. And that's a way that you can do it, but it's not super efficient because you have to select each element in the array and ask, is this one 57? And that's potentially all of them in case the last element in the array is the one that you're looking for. It's the 57. That's not the dream. And if you're following along with big O notation, like we were talking about in the last video, or if you just happen to know it in life, the time complexity of that is O of n. Wouldn't it be nice if there was a way to pare that time down? And is there something about this array, this sorted array of 1 through 100, that you can take advantage of that gives you a smaller than O of n time? Well, if you said the fact that it's sorted can be taken advantage of, then you're correct, because that's exactly, and that is exactly what we'll do. Wikipedia helpfully gives the following definition for what makes binary searches what they are. And that is, a binary search compares the target value to the middle element of the array. If they are unequal, the half in which the target cannot lie is eliminated, and the search continues on the remaining half until it is successful. So look at this picture here. It's kind of small, but I'll try to zoom in. So this is how that works. So you're looking for 7, and you compare it to the middle element of this array, and you say, okay, 7 is less than 14, so we're going to look at this half right here. Now we're going to compare it to 6. Okay, well, it's bigger than 6, so we're going to compare it to this half. Okay, well, the middle value is 8, 7 is less than 8, so now we're going to compare it to just this, and we're going to look at the middle array, or the middle value here. It's 7, that's the number we're looking for, and we're done. It's great. Now, before we go on to pseudocode and decoding it, I'd like to point out some of the O notations that you'd find out. The best case performance is that it's O of 1, and you'd get that in the case that the very first middle value that you look for, or that you look at, the very first iteration, is the number that you're looking for. The worst case is log n, because chances are the first one that you look for will not be it, and that it will in fact be somewhere in there, and you have to iterate a couple times, bisecting the array each time. So I hope that all makes sense, and we'll get a little more concrete right now as we first come up with some pseudocode, and then some actual code. We'll be implementing it in Ruby. So let's set up a context for our binary search method. We need inputs, which, well, and we need two inputs in particular. We need an array to be searched, and we need the search value. So for the array to be searched, let's say an array of 1 to 1,000. And for the search value, we'll say 57. Now we need to create an array that will take 4 inputs, which are the search value, the sorted array, and a range to search, which we'll just call from and to. From is the beginning of the range, to is the end of the range, and those are indexes of which will then be used in the array. You can do a binary search without the from and to, but we're doing that way for this particular version. Now we need to check if the end value is defined or not. Initially it will be set to nil, and we'll pass values explicitly later. You'll see that more when we actually do the code. So that's the context of the method. Now inside the method, we need to define the range that we're searching and find the midpoint. To start out with, we'll infer that the range is index 0 for the from, and then the to is array.length minus 1. So we're basically going from the very beginning of the array all the way to the very end. And then the midpoint is the average of 0 and then array.length minus 1. So it's 0 plus array.length minus 1 divided by 2, and we'll set that to be a variable called mid. Now we have our beginning, middle, and end, and so we have to set up a conditional to ask if the search value is more or less than the value at the midpoint. If it's greater, we'll call the binary search method again, but only on the second half of the array. And if the search value is less than the value at the midpoint, then we'll call the binary search method on the first half of the array. And if it's equal, then we're done searching and can return the mid index, as it's the thing that we're looking for. So I know that was a lot to take in. It's about to get more clear as we look at the actual code itself. Here it is. So we have our array, which is 0 to 1,000, and then we have our method here, and it takes the array, it takes the value, and then our from and to. If the to is nil, meaning it's the first time that we're running it, and you'll see we pass them explicitly later on. If it's nil, or if it's the first time we've run through this recursive method, then we'll set the to be array.count minus 1, or the last element of the array. And then of course mid is from plus 2 divided by 2. And then here's the conditional. So if the value, this is the search value, is less than the value at the midpoint of the array, then we call binary search. And then if it's greater, the search value is greater than the value at the midpoint of the array, binary search again. And if it's, so we've covered less than, we've covered greater than, and if it's equal, then we put the index itself. So there are these two cases where we're doing recursion, right? What in particular are we passing to subsequent calls of the binary search? Still the array, still the same search value. That's the same in both cases. Where it gets a little bit tricky, where you have to pay close attention, is the fact that the from and to change. So for here, this less than case, we're calling binary search again on the left half of the array. So from, and it's going to still be 0. From, and then mid minus 1. That's the left half of the array. Mid plus 1, so, and then 2, which is array.count minus 1, which is the end of the array. So this is the right side, this is the left side. And it's going to keep going and keep going until it finds the one that we're looking for. So I will run this for you. You'll see it at the bottom. And let me put in some text to show you what's happening. All right, so I added this text and then I ran it again. I put in these lines here to show you how the recursion progresses. So what's the midpoint of an array that's 0 to 1,000? It's 500. So we see that the search value, which is 42 here, is less than 500. So we end up hitting this condition and calling binary search here. It's now we see again less than 249, so this condition gets hit again. It's smaller than the midpoint of that, which is 124, so this gets hit again. It's smaller than 61, so it gets hit again. But the midpoint now is 30, which is larger, and so we hit this condition, and it's larger than 30, so we call this here. This happens a couple more times, 45, 37, 41, 43, we're dancing right around it, hitting various conditions of greater and smaller than. And then ultimately, we find the search value 42 can be found at index 42, which makes sense because we're starting 0 to 1,000. So the index numbers and the values at those numbers are equivalent. If I had said 1 to 1,000 and then reran it, it would be 1 off from where it is now. But I thought it would be easier to have it be an array of 0 to 1,000, so the index numbers and values are the same. But anyways, that's basically how a binary search works. I would encourage you to implement it on your own. Look up some resources online, and I hope you enjoyed it and found it helpful, and I'll see you all in the next one.